Alright, let's talk about how we can use an algebra shortcut and specifically solving an equation and then taking the square root so that we can figure out the x-intercepts of this graph here, y equals x squared minus 9. So you see here the x-intercepts, remember again, those are the points where this graph is crossing our x-axis. It's these points where y equals 0. So in this case, I've drawn a graph for you so we can see that those x-intercepts are when x equals -3 and when x equals +3. So that's fine. We could look at a graph and figure out the x-intercepts, but we don't always want to have to draw the graph first to figure that out. So here's the shortcut we can use. Well, we can think about this and say, I want to know when y equals 0. So step 1 here is let's set y equal to 0 so that we can set up an equation that we'll be able to solve. So what that looks like with this equation we have is 0 equals -x squared plus 9. Now we're going to solve this equation, so we want to get the x squared so that it's by itself so that we can end up taking a square root. So let's move this x squared now over to the other side because I see here I have a minus x squared. So if I want to do the inverse operation of that, I could add x squared to both sides of my equal sign. And I'll put this down here. Then that's going to get us to x squared equals 9. And now I'm in a position to go through with step 3 where I can take the square root of both sides of this equation so that all I'm left with is x, right? Because the reason that we added x squared up here to both sides is because that is the inverse operation of subtracting the x squared that I started off with. Well, the inverse operation of squaring something is taking the square root. So let's do that inverse operation to both sides now. And I'm left with just x on one side, which is what I want, equals the square root of 9. And we have to remember here that there isn't just one answer, right? Because I know that 3 is usually the first thing we think of when we're taking the square root of 9. But look at our graph here. There's actually a couple of answers to this problem when we're trying to find these x-intercepts. So we can't we can't forget that x could be 3 or x could be -3. So we write that as x equals plus or minus 3. And this is my answer. And the reason that both of these things work is because if you square 3, you're going to get 9. But if you square -3, you're also going to get 9. So if I'm asking, well, what's a number that I can plug in for x so that I square it and get 9? I could do +3 or -3. So that's why our answer here is plus or minus 3. Let's look at another slightly more complicated example, and let's find the x-intercepts, whereas y equals 0 of this function here. So I'm going to go through the same steps. So first, I want to set y equal to 0. And remember that this f of x here, this is the output of a function, and the output of a function gets mapped on our y-axis. So setting y equal to 0 is the same thing as setting f of x equal to 0. So if I want to figure out where this is going to cross the x-axis, I want to know when is y equal to 0. So first, let's set f of x equal to 0, and I have 25 minus 5x squared. And now again, my process is I want to get it so that eventually I have something like this. X squared equals something that I can take the square root of to figure out what x is. So let's get x by itself. So I notice here that I am subtracting 5x squared. So let's move this over to the other side by adding 5x squared to both sides. And then I'll have 5x squared equals 25. And now I still have one more step I need to do right before I'm in a position like I want up here where I just have x squared by itself. I notice here I am multiplying by 5. That's what it means when I write this number in front of my x squared. So how can I undo multiplying by 5? Well, the inverse operation of that is I can divide both sides by 5. So now that's going to get us to x squared equals 25 divided by 5 is 5. And now we are in a position to take a square root and get our final solutions. So let's take the square root of both sides. And remember, I want to take both the positive and the negative square root of 5. And can I simplify this any further? Well, if I wanted to plug this into a calculator, I could get some number with a decimal. But we know 5 is not a perfect square. In other words, there's no integer number that I can square to get 5. So this is the simplest that I can do without a calculator. So we're just going to leave this like this, and we call this a radical in simplest form because I couldn't make this any simpler without plugging it into a calculator and getting some number with a decimal. So we could, again, use a calculator, but it's going to be some messy number with a decimal, so this actually looks cleaner. So let's just leave it like this, and now I know that if I drew a graph of this function, the x-intercepts would be the points where x is the positive square root of 5 and the negative square root of 5. Let's do another example where we have to solve an equation. And here I don't have a function with a y or an f of x. I just have this equation and it's just telling me solve. So if you're given a function, then when I say solve, I'm saying find the x values that make y equal to 0. If I just give you an equation like this and I say solve, now what I want you to do is find the x values that are going to make this equal sign true. So basically it's the same process, but this is like if we jumped in after we had already set one side equal to 0. And you can imagine, actually, if I had started off with some function like y equals 3 times x minus 2 squared minus, I think it's going to end up being 36. So this problem is actually connected to a similar problem. If I wanted to find the x-intercepts of this function here, well then I would set y equal to 0, and I would end up getting 3 times x minus 2 squared minus 36. I could move stuff over to the other side and solve it in the same way. So don't get confused when you have a problem where there's not a y in the picture. If there is a y, your first step is going to be set y equal to 0. If you don't have that y to start off with, then you don't have to set y equal to 0 to start. You can just go from this point that you are given here. So let's solve this by the same process. I'm going to use inverse operations to move things over to the other side. So first thing I can notice is I have this minus 21 here. So let's add 21 to both sides. And now I will have 36 equals 3 times x minus 2 squared. Alright, next thing I want to do is get rid of this multiplying by 3. And now I don't want to distribute here because that's actually going to end up making this side more complicated. And what I'm trying to do is make this side simpler, right? So instead of distributing here, let's divide by 3 to move this 3 over to the other side. And now I have 12 equals x minus 2 squared. And now I'm in a position where I can take the square root of both sides to get rid of this squared that I see here. So in the previous problem, in our final step, we had something like x squared equals, and then we had something over here, and we took the square root of both sides. Now notice here, what we have is we have an x minus 2 squared. But I can still use the same process. I can still take the square root of both sides to get rid of that square there. Square root is still the inverse operation I want to use. So when I take the square root of both sides here, I need to remember, again, to take both the positive and the negative square root of 12, and that's going to give me x minus 2, since I undid that square with my inverse operation. And the square root of 12 can be simplified further, right? Because 12 is equal to 4 times 3. So I can actually break this square root apart into 2 of its factors, and I notice that this is a perfect square. The square root of 4 is 2, whereas 3 I can't simplify any further. So plus or minus square root of 12 is going to be the same thing as plus or minus square root of 4 times square root of 3, which is going to be plus or minus 2 times the square root of 3. And we're not done yet because, remember, we still have what's left on this side of the equation. We have x minus 2. So at this point, I have x minus 2 equals plus or minus 2 square root of 3. And my final step is I'm going to need to move this minus 2 over to the other side. So let's add 2 to both sides. Add 2 to both sides, there we go. And we have x equals 2 plus or minus 2 times the square root of 3.